Hi, now we are going to write a Python program. Actually, we started with a high level breadth-first search algorithm, then a detailed algorithm. We have considered an example and you had a walkthrough. After all these things, in this section, we are going to write a Python program. See, first of all, we must know that a graph is completely represented by an adjacency matrix. Look at it. This is the graph that we are going to consider, and the adjacency matrix is given below. If there are 7 vertices, it is represented by a 7 by 7 matrix in which each entry is either 0 or 1. For example, 0 is not adjacent to 0, so it is a 0. 0 is adjacent to 1, so 0, 1 is 1. 0 is not adjacent to 2, so 0, 2 is 0. So it is not adjacent to anything except 6. So look at it, 0 is adjacent to 1 and 6. So in the 0th row, 1 and 6 will be 1, all others will be zeros. Similarly, if you consider 1 is adjacent to 0, 2, 4 and 6. So 1 is adjacent to 0, 2, 4, 6. So those 0, 1, 2, 4, 6, they are 1. All others are zeros. Similarly, 2, 3, 4. So the adjacency matrix fully represents the graph. This is important. Now we are going to write a Python method, a def function called BFS. Look at it, BFS. And this will be given G as the input. G is the adjacency matrix. If it has 7 nodes, it's a 7 by 7 matrix. If it has 15 nodes, it is a 15 by 15 matrix. So G is a matrix. In Python, a matrix is represented as a 2-dimensional list. So G is such a list. And init is the node where we start, the initial node. So there are 2 inputs, G and init, 2 inputs. What is the output? Output will be the node which has the solution. If a particular node has the solution, that is the output, and the path cost will also be given. If it is not available, then finally we will come out saying, no, it is not available. So that is how we are going to write a Python program. Look at it. So here, in the initialization phase, we must look at the variables. What are the variables? Variable n is the number of nodes. Path cost is the distance from the initial node to I. That is the level. Path cost and the level will be equal. This is a Python list where solution I equal to true if node I has the solution, false if I doesn't have a solution. If it is available in 5, solution of 5 will be true. Otherwise, it will be 0. So, explode is a set. Q is a list level parent. So, we define def BFS of G, init. Look at it. Def BFS of G, init. What is n? If you find the length of G, that is n, number of rows in G. Initially, we will have path cost is 0, so path cost equal to 0 for I in the range of n. So path cost of 0 is 0, path cost of 1 is 0, path cost of 2 is 0, n minus 1 is 0. So for all of them, it is 0. Similarly, solution equal to false for I in the range. So we are going to assume that it is not available anywhere, so that it will explore everything and come out. We want to see how it is happening. Similarly, parent of 0 is 0, parent of 1 is 0 and so on. Level, explode equal to set of empty. So explode, I'm going to have it as a Python set. Q is empty. So we have initialized from line 1 to 14. Now for a understanding, in fact, when we write a program, if every intermediate stage, if it is the printing, it will be good. So print iteration number, explode set, queue, path cost, all the data structures we are printing. Afterwards, we begin. Node equal to init. So we begin with the initial node. Print number of nodes in the graph. You can print n because we have found out n already. N equal to length of g. So we can print. And now if solution of init is true, then that has the solution. So print success and path cost 0. That's all. It is already available. Return init and the path cost of init. The path cost of init is 0. Otherwise, what are we going to do? After checking, we can do that. Now we will append the node to the queue. Now iteration equal to 0. So this is an initial check. Now for iteration 0, what are we going to do? So we have added 0 to the queue. Now if you look at this is actually the algorithm that has been implemented in Python. Look at it. When length of queue is greater than 0, it means when the queue is not empty. If it is empty, we will stop. What are the things to be done? Node equal to queue. So we are pop the first entry. Now print explore processing node for our printing. Now explode dot add of node, because we have a set called explode. So you add node there. Now after adding, for child in range of n, because a child 0, 1, 2, 3, 4, 5, 6, all. We don't know what is the child. How do you find out whether it is a child? Now g of node comma child. If it is 1, it means node and child are adjacent. So if you check g of node comma child, node child equal to 1, it means node and child are adjacent. So if it is adjacent, we have to check two things. If not child in explode, it should not be in the explode set and it should not be in the queue. So if not of child in explode or child in, it means it is neither in explode set nor in the queue. If that is the case, what are we going to do? Path cost of child equal to path cost plus 1, because that is going to be considered. Now level also is become incremented. Who is the parent of the child? Node. Now if solution of child, it is a success and we will stop. Otherwise, you append to the queue. So all these things we will verify. So explode, it will be checked. If it is not, then we will consider all the children and verify two conditions. If those two conditions are satisfied, we will add it to the queue. Now print again, all of them print, and iteration equal to iteration plus 1, and repeat the while loop. So the while loop will be repeated. When it comes out, there are two possibilities. One is already found the solution and it comes out. If that is the case, length of the queue will not be 0. If length of the queue is 0, it means we have verified everywhere but the solution is not available. So return -1 comma path cost. Otherwise, if it is already there, it would have return child comma path cost of child. So this is the way the method is created. After creating the method, you consider the data. So G1 equal to this matrix. Now if you say node comma path cost equal to, you call the method path cost of G1 comma 0. And now node will have the result. Look at it. If I run for this example, which is this graph, we have already seen. Look at it. Iteration, initialization. So number of nodes in 7 and number entering queue 1, entering queue 6. So initially 1 and 6 enter the queue. Then next iteration, explore node 1. When node 1 is explored, what is entering the queue? 2 and 4. We have already seen this example. Then in the next iteration, explored set will be 0 and 1. 0 is explored, 1 is also explored. Now 6 is taken up. Now explore processing of node 6. Now at that time 5 enters the queue. So now queue is 2, 4, 5. Then iteration 3. In iteration 3, explored set is 0, 1, 2, 6. Because the 2 is also explored here. Now 4, 5, 3 are in the queue. Now we are going to explore node 4 because 4, 5, 3 is the queue. Then iteration 4, iteration 5, iteration 6 and so on. Now if you look at the BFS tree parents, parent of 0 is 0, parent of 1 is 0, parent of 2 is 1. Look at it, parent of 2 is 1, parent of 3 is 2, parent of 3 is 2. So the parent array, parent list will tell you how is the BFS tree created. Now in the same program, you can also give the input of another graph. For example, here is another graph which has 10 vertices. So here, this is the graph 0, 1, 2, 3, 4, 5, 6. So this is the graph and this is the adjacency matrix. What I do is, I am going to consider giving this graph having 10 vertices. Look at it. This is the output. You can verify for this is the output. Iteration 6, 7, 8, 9. So if you analyze, so this is going to be the tree, BFS tree. In a similar manner, I have also considered another example with 15 vertices. So the program is the same. You just change only G. Look at it. If you use the same method, you get the result. Look at it. So you can verify whether it gives you everything. The analysis is this. This is the graph. So we write a method called BFS and that will give you the result. So if you write it as a method for various graphs, you can use the same method and get the output. I have shown you 3 examples. Similarly, you can try for the rest of them. This document is available here as a downloadable document. You can download it and write your own program and test it. Only then you will understand it better. Thank you very much.